Hey guys, this is section 2.2. We're going to take a look at some more stuff about functions and their graphs. And we're going to start with talking about functions being increasing or decreasing. And if we have a graph, it's simple enough to tell as we go on, right, as we go to the right, from left to right, that's reading order. If it's going up, that's increasing. So if it kind of goes up, that's increasing. And if it goes down, as we go to the right, if it goes down, has that kind of a slope, decrease. So we can come up with some nice examples here. One would be a function that does something like this. And then over here it's increasing until it hits its apex right here. And from then on, this function is decreasing. We could have something like this, where this is increasing. And then if it's still increasing a little bit in here, if it's still kind of gradually going upwards, but just very slightly, then that's still increasing. And then up here it turns and it's even more increasing. So that would be everywhere increasing. Or maybe we could have something like this. Where this is constant, right? Neither increasing nor decreasing, constant. Until right here, and then it's decreasing. So visually, does it point up, does it point down, or does it lie flat? Increasing, decreasing, or constant. We can describe that algebraically. And to do that, it's a little complicated. We have to say, okay, let x1, we'll say, come before x2. So that's what that means. Then, if f of x1 is less than or equal to f of x2, increasing, f of x1 is greater than or equal to f of x2, decreasing, f of x1 is equal to f of x2, constant. And then we can further get a little bit more specific by saying for all x1 and x2 on some range so we could instead specify that there's some range that these values come into play, and if x1 is less than x2 on that range, like the range 3, 7, anytime I pick one smaller, it's f of 3 is less than f of 4 is less than f of 5, etc. That's increasing. Make a sequence of x's going from small to big. If the f of x's also go small to big, then you have an increasing function. But visually, downright simple. Do it point up, do it point down. Also relatively simple to look at on a graph is relative extrema. I'm going to draw a nice little curvy line right here. Right here, take a look at that. It's going up and then it switches to going down. That point right there, that's a relative maximum. It's not an absolute maximum because if I jump over here, this point's higher. But within a region about it, it's the highest point around. Likewise, over here, right about at 0, it's decreasing and then it switches to increasing. So this is the lowest point around. Again, if I go like over here to x equals -6, I'm going to find something lower. But relatively speaking, it's a minimum. The other word for that is a local minimum or a local maximum. Okay, it's the greatest point, the greatest f of x in some region. It's the smallest point, the smallest f of x in some region. What about even and odd? An even function is a function where it doesn't matter if you put a negative x in, and it picks up the name even from looking at f of x is equal to x squared. If I put negative x into here, what do we get? Negative x quantity squared. So f of negative x is, after we simplify, x squared. And what's x squared? F of x. It's an even function. What about something like g over here? G of negative x is negative x to the fourth minus 1, which is x to the fourth minus 1, which is g of x. This is even too. This f of x, let's stick in again a negative x and see what we get. We get the absolute value of negative x minus negative x to the fourth. Well, it doesn't matter if this is positive or negative, it's the absolute value of x. And we simplify here and we get minus x to the fourth. F of negative x is f of x. Contrast that with what happens with g. I stick a negative sign in and we get negative x cubed. Negative 2 cubed is negative 8. 2 cubed is 8. Whoops. That's not g of x, so that's not even. What is it? Well, it's odd. If I take a look at f of negative x, and I have negative x cubed, well, that's going to be negative x cubed. The parentheses go away. And what is that? Why, that happens to be negative f of x, the exact opposite of f of x. And when f of x is when f of negative x is equal to negative f of x, the negative sign in a sense jumps outside of those parentheses. That means it's an odd function. And that's the case over here for g of x. G of negative x is equal to negative x cubed minus negative x. That's negative x cubed plus x. Both signs change. That's negative the function. What about for this f of x? F of negative x is equal to the absolute value of negative x. Absolute value of x. Nope, that would be even. We looked at that already. H of x, though, might be, because look, that's odd. H of negative x is negative x to the 7th minus 3. So that's negative x to the 7th minus 3. Shoot. This sign changed, and that's good. But this sign didn't, and that's bad. So this is neither. It's not even, it's not odd. It's neither. So let's make use of this calculator to take a look at what the graphs of even and odd functions look like. I'm going to put an even function in to start with, and we'll start with a simple one here. X squared. Zoom standard. What does this look like? I'm going to tell you what's happening here, what I'm looking at. I'm seeing that it's symmetric about this line right here. Okay, let's try another even function. Let's try x to the 6th minus x to the 4th. That's even. It's all even powers. It's going to be even. Let's graph it, see what happens. Yeah, look at that. Symmetric about the line x equals 0. So if I'm graphing something like this even, it's got symmetry about the vertical line x equals 0. So that would look something like this. Here's the line x equals 0. My graph will come in and it'll do something weird like that, and then it'll have to do it all over again coming back out. Symmetry. What about some odd graphs? Let's do x, that's odd. Let's do x cubed, that's also odd, and we'll do x to the 5th. I'm going to do actually 0.5 times x to the 5th minus x. There's y equals x. That's x cubed. And that's my other one. Can't really see too much going on there, so I'm going to zoom in a little bit. I'm going to hope that once I zoom in, I can really see what's going on. Okay, look at this. As this comes along here, it comes up, it gets here, and then it goes back out and then back in. So this hump, this little bump, and this one right over here, this bump, match. This hump and this hump, these match, these bulges match. So if I have an odd graph, it's symmetric about the line y equals x. So if I draw that line, looks something like this, and I would go out, come out, come in, and then I'd have to do the exact same thing like that, and that would be odd. It does look quite odd. Okay, moving on. What about piecewise functions? Bye-bye for now, calculator. Piecewise functions are defined in parts, hence piecewise. And I figure out where in the little subdomains I am, and then that tells me what's happening. So for my first one, f of x is equal to 0 if x is odd. So 0, not odd. 1, that's odd. So f of x is 0. 2, not odd. 3, odd. 4, not odd. 5, that's odd. Otherwise, it's 1. So what does this look like? It looks like that. Something like that. Interesting. G of x is equal to x squared if x is greater than or equal to 0. So over here in positive land, it's x squared. Whereas over here, less than 0, it's the absolute value of x. Let's actually make that purple, make it stand out. So here's the absolute value of x, and it's not that at 0, so I'm going to draw a nice little hole, and it's the absolute value of x. And then over here, in the positive region, it's x squared. So it starts at 0, and then it comes up. And these connect right here, but they don't have to connect. We can have holes in the graph and discontinuities. Lastly, we've got h of x, and this has got a lot going on, and I want to use that as an example of finding values for piecewise functions. Let's first find h of 10. Is 10 greater than 10? No. Is 10 less than or equal to 10 and greater than 0? Yes. Is 10 less than 0? No. See how 10 fits into only one of these little subdomains here? Only one, just this one? That's what we need from a piecewise function. So, if that's the case, it fits right here. I'm going to follow back and I'm going to look at x minus 1. So that's going to be 10 minus 1. So h of 10 is equal to 9. What about negative 3? Is negative 3 greater than 10? No. Is it in here? No. Is it less than 0? Yes, it sure is. So I'm going to take and do its 3x, so 3 times negative 3, that's negative 9. h of negative 3 is negative 9. And that is how we evaluate a piecewise function. Lastly, let's take a look at the difference quotient. So I've got the difference quotient written out right here. It's, oops, pardon me. Let's take a look at the difference quotient here. I've got the difference quotient written out. It's f of x plus h minus f of x divided by h. This is very important for calculus. And this is the general method of how you do it. So we're going to take f of x is equal to x squared, and we're going to find its difference quotient. I'm going to start off by finding f of x plus h. Oops. I'm going to find f of x plus h. So that's x plus h squared. I just make that substitution, and I'm going to expand it. We're always going to want to expand these things. X squared plus 2xh plus h squared. Great. And now I'm going to find f of x plus h minus f of x. So it's this expanded form, x squared plus 2xh plus h squared, and then I'm going to subtract f of x, so minus x squared, and now I'm going to once again simplify. X squared minus x squared, we're left with 2xh plus h squared, and now we divide everything by h. F of x plus h minus f of x divided by h. 2xh plus h squared divided by h. Do you see what I see? Because I see an h, an h, and an h. I see division giving us 2x plus h. And indeed that's the case, and that's how these generally go. We figure out f of x plus h. We do a little simplifying and see what's going to cancel. We divide and look for the h's to reduce out. And then we have our simplified difference quotient. Let's do this all again for g. And g of x is equal to x squared minus 3x. So we're going to start by finding g of x plus h. So that's x plus h squared minus 3 times x plus h, and we simplify this all out to 2x, or 2, pardon me. I'm jumping ahead, I'm getting ahead of myself. X squared plus 2xh plus h squared minus 3x minus 3h. Okay, and now we're going to take g of x plus h, and we're going to subtract from it g of x. And you know what? Let's do this in columns. So it's going to be minus x squared plus 3x. Those cancel out. And let's figure out what all remains. 2xh plus h squared minus 3h. Ooh, great. Everything's in terms of h. So I'm going to take all of this and I'm going to divide it all by h. And we get the difference quotient 2x plus h minus 3. Wow. All right. And that's finding difference quotients. So that's it. I'll see you next video where we will work some examples. Thanks. Have a good one.